Okay, so in the previous video we saw what confidence intervals are and why we use them, and how they work. Now we're going to talk about how we construct confidence intervals for a population proportion. Right? Again, in this short PowerPoint, we're going to see what we get from a confidence interval for a sample proportion or population proportion, what we need to calculate the confidence interval, how do we interpret a margin of error, and how do we interpret a confidence interval. Again, remember that the goal here is to estimate a population proportion using sample data. Right? We will never be able to calculate the actual population proportion. That's the premise we start from, because the population is so large that we will never be able to observe it all. But we can get a pretty close estimate using one sample, and that's why we do this. And again, we do this, we do confidence intervals because we want to deal with the problem of sampling error. Right? Our sample is likely to differ from the population proportion because of sampling error, and we do confidence intervals to deal with this sampling error and still be accurate when we talk about the population parameter. So in order to calculate a confidence interval for a proportion, you need the sample proportion, the sample size, and an idea of how accurate you want to be. Right? You want to be 90% sure on whether your confidence interval includes the population parameter. You want to be 95% sure, or you want to be 99% sure. Right? So once you have those three things, you can calculate confidence interval for a proportion. Now, the formula we use is this one. So the confidence interval is equal to the sample proportion plus and minus, right? Plus or minus the square root of the sample proportion times 1 minus the sample proportion divided by the sample size. Right? N is the sample size. It is a lot simpler than it looks like in that formula. Now this little part here, after the plus and minus signs, is called the margin of error. And the margin of error tells you how far you may be from the population proportion, right, for the degree of confidence you chose. And how far, either above or below, the population proportion may be from this sample proportion. Okay, we'll talk about this, give you an example. Now, suppose that we obtain a sample of 10 CHHS students, and we calculate the sample proportion for the proportion of students who are orange, right? Or for all the colors, for that matter. So the proportion of orange students is 0.4, right? I got that by dividing 4 divided by the sample size, right? That's 0.4, or 40% of the students are orange in my sample, 20% are green, 10% are pink, and 30% are blue. Now, we don't know what the population looks like. Right? We don't know. We will never be able to observe what it is. But suppose we want to calculate what is the proportion of orange students in the population. Right? So, our sample size here is 10. We collected 10 students from the population, and we did it randomly. The sample proportion of orange students is 0.4. Right? 40% of students in our sample are orange. And suppose we want to be 95% confident of our results when we talk about the population of students who are orange. Okay, so this is the formula. The sample proportion of orange students is 0.4. Sample size is 10. Now, Z here is the critical value that we talked about, right? we said that if we want to be, if we want to be 90% sure, right, our z-value is 1.64. If we want to be 95% sure, our z-value is 1.96. And if we want to be 99% sure, our z-value is 2.57. Right? Now let's go back here. We want to be 95% sure in our example, so z is 1.96. Now these values don't change for proportions, they are always the same. For 95, it'll always be 1.96 regardless of the sample size. When we're doing confidence intervals for the mean, that changes. Alright, so we plug in the numbers in the formula, and we get that the margin of error is 0.3. Right? That tells us that our estimate may be 0.3 away from the population proportion. Right? And we're 95% sure about that. We're 95% sure that our sample estimate, right, is 0.3 away from the population proportion, and we're 95% sure of that. Right. So we add this margin of error to the sample proportion and then subtract this margin of error from the sample proportion to calculate the confidence interval. The confidence interval will have a lower bound or an upper bound. The lower bound is 0.1, that comes from 0.4 minus 0.3, and the upper bound is 0.7, that comes from 0.4 plus 0.3. Right? So our confidence interval tells us that we are 95% sure that the population proportion is between 0.1 and 0.7. Okay? Now, let's look at this graphically. We have the sample proportion here, and we calculated the margin of error, that's 0.3. Right? So we add that 0.3 to the 0.4, that gives us 0.7. We subtract the 0.3 from 0.4, and that gives us the 0.1. Right? Again, the margin of error tells you that your estimate may be 0.3 away from the population proportion. Now, we don't know where the population proportion is. We don't know. We will never know that. But we are 95% sure that it falls somewhere between 0.1 and 0.7. Right? We are 95% sure that a population proportion falls between 0.1 and 0.7. Right? Now let's see. The actual population proportion is 0.65. 65%. 0.65 falls around here. Right? So our interval has the population proportion in it. Right? So it was correct, and you know that's to be expected. We'll be correct in our confidence interval 95% of the time. Right? So chances are that you will be correct. Right? At least 95% of the time. Our margin of error said that we could be 0.3 away from the population proportion with 95% confidence, and we were. Right? So that's what that's how you calculate a confidence interval for a population proportion. Now, you can reduce the sampling error. You can reduce the size of the sampling error. Right now, if you really take a look at it, this is pretty wide, right? We can say, well, we're 95% sure that between 10% of the students and 70% of the students in the population are orange. Now, that includes pretty much the entire range, right? That's not a pretty accurate or pretty, it is accurate, but it's not really precise, right? We have a large margin of error here, right? We can be, 30 percentage points away from the real population proportion. We can reduce this. Now, The size of the margin of error is a function of three things, and you can figure this out when you look at the formula, right? One is the confidence level you want to have. The more confidence, the bigger the margin of error, right? This is what gives you the Z, right? If you want to be 95% confident, your Z is lower than when you want to be 95% confident. So that allows you to reduce the sampling and the margin of error, but gives you, it's less accurate, but it's more precise. The sample size. The larger the sample size, the smaller the margin of error. And this is pretty much the only thing that you can control for a given confidence level. This is the only thing you can control, right? The sample size. So if you want more precise estimates, smaller sampling margins of error, you increase the sample size, right? The third thing that can change the size of the margin of error is the sample proportion itself, right? The closer it is to 0.5, the sample proportion, right, the larger the margin of error. And the further it is from 0.5, the smaller the margin of error. But again, you can't control this, right? You get what you get. The only thing you can control for a given confidence level is the sample size, right? You want more precise estimates, get a larger sample size. So in summary, to calculate confidence intervals for a proportion, we need a sample proportion, a sample size, a z-value associated with a required degree of confidence, right? The formula is this one. Z is the value that comes from a z-distribution, right? And that's associated with the degree of confidence. If you want to be 90% confident, then z is 1.65. If you want to be 95% confident, z is 1.96. If you want to be 99% confident, z is 2.57, regardless of the sample size. The margin of error tells us how far our sample estimate may be from the population proportion for the degree of confidence we choose. And we interpret confidence intervals in the following manner. We are 95% confident, if we chose this, that the population proportion is between, right, the lower bound of the confidence interval and the higher bound of the confidence interval. In the next video, I'm going to show you how to calculate this on Excel using a real sample. Thanks for watching.